My name's Jamie. My talk is based on a blog post that I wrote several months ago. The blog post is here. It contains slightly different, more information, let's say. This is slightly stripped down, slightly reworked. So the talk is based on observations that I think I've made, trends I think I've seen in the industry in the last couple of years. It's titled, Did Virtualization Create DevOps? And Will Containerisation Destroy It? Okay, I'm interested in the change that I've seen. I think I've seen sort of cause and effect in certain places, and with that in mind, I'm interested in this definition of potential energy. In physics, potential energy is the energy that an object has due to its position or the configuration of its parts. So, hands up, anyone who had a feature phone a little bit like this many years ago? So what were you running on that? Was iOS? Was it Android 5, 4, 3? So first observation is it's very simple. Changes in hardware create potential for change in software. And we've all seen the rapid change within the mobile technology world. And hands up, anyone who knows the name of their bank manager? Not a single person. Me neither.
Bank manager.
Yeah. So changes in software, advances in software, such as operating systems, apps, web services, they give us options, they give us choice, and that empowers us to do things differently. So we have advances in software which are creating potential change in people. We choose to bank online. So in the 90s, server hardware, generally speaking, very little processing power, very little memory. As a consequence of that, we would have a lot of servers, and we'd probably have quite a lot of ops people to look after those servers. This is my ops character, by the way. We also had, well, servers were, relatively speaking, very expensive. So we installed as much as we could on one server to get our money's worth, risk allowing. This resulted in having a pretty complex server stack. It meant that we had it took a long time to build or to rebuild the server. And this meant that our focus was on mean time between failure, because we wanted to make sure that was a long period. We had a good mean time between failure. That resulted in a fear of breakage. And we, as ops, were very defensive about anyone else touching the servers. As a result of that, devs didn't really get a chance to have a relationship, get familiar with the servers. In the 2000s, we see a lot of advances in hardware. We start to get servers which are extremely powerful, more powerful than you need to run a single application stack on a single server, maybe with the exception of databases. And this change in this advance in hardware creates the potential for change within software. And we see virtualization arrive. Hypervisors appear which allow us to virtualize. So if we look at the stack on the left, this is more traditional hardware bare metal stack. There's a one-to-one relationship between the server hardware and the operating system. But if we look at the one on the right, where we've introduced the hypervisor and we've done virtualization, we've abstracted the layer between the server hardware and the operating system, and we've broken that one-to-one relationship. We've got a one-to-many relationship with many operating systems as virtual machines on one piece of hardware. Now you can get, I'm sure people who've worked in this area, you've seen tens or even hundreds of virtual machines on a piece of single server. This creates a problem. This problem is about managing many systems. So the solution to this problem is in software. The solution is configuration management. And this change in software, this advancement in software, creates potential change within people, in this case devs. The configuration management provides a familiarity in language construct, because we're now able to provide a tool to people outside of the ops world to build these servers, and the tool uses constructs language which describe the code, or sorry, the code that is used describes the infrastructure in a way that developers were more familiar with. Also, the option to manage servers via web console was different to having to go and ask someone to spin you up a server. So you now have an interface. So this empowered developers, and they began to get a closer relationship with servers. So if we look at the areas of responsibility, ops, sorry, this is our stack here with a hypervisor, and then just a single VM here. Ops have got responsibility for server hardware, for the hypervisor, for the operating system. Devs have responsibility for the application layer. If we bring in our solution to the problem, we talked about the configuration management tools. We see that the configuration management starts just above the base operating system install. It adds in extra operating system packages, and then it builds the application on top of that. But what we've got here with the using configuration management, with both operations and devs having a stake in using configuration management to build, we've created this gray area. And in this gray area, it's not obvious who owns it. They're both stakeholders of this gray area. So the ops guys, they need these extra operating system packages for NTP, for monitoring clients, for user accounts, things like that. The dev guys, they need extra operating system packages for libraries for their application, for say Python libraries, for a Java install. So it turns out that the best way to solve this problem, to divide this area between the two stakeholders, is to get them to work together. And so as crude a definition as this is, we have a viable DevOps scenario. This, I didn't mention, is obviously my little dev character. So in the 2010s, the 2010s, software advances, and we see containerisation arrive. We see Docker leading the charge. We see Rocket sort of coming along as well. And we see sort of more work with LXC and LXD. So if we look again at the breakdown here, we have on the left, without any containerisation, a one-to-one relationship between the operating system and the application level. On the right, with the container platform in place, we have again created an abstraction between the operating system and the application layer. We've broken the one-to-one relationship, and we've got a one-to-many relationship between the operating system and the application layer. And we have again created a problem of managing many app containers. So the solution to this problem lies in software. It's container management and it's container build tools. The advance in software can create potential change in people. So I wonder what the consequences are for the people who now have more tools and more choices. So if we look on the left, we can see areas of responsibility. We can see that the gray area that we defined earlier, where both the devs and ops have a shared area of responsibility. On the right, we can see the sort of same stack with the container platform inserted. Notice that the extra OS packages that the app needs are sitting above the container platform, because if you want to run the same application with different versions of the same operating system package, you want to get that operating system package up into the application container. So it's sitting up there as part of the container. Then next we've got the container platform. This is actually part of the extra operating system packages for the base OS. Obviously, we can't put an app container up there without the container platform installed. And so it has to go on there at that stage. So we introduced our tools. We can see that the configuration management tool on the left here starts above the base OS, builds the extra operating system packages, and builds the app layer on the right. Similar start above the base OS, extra operating system packages including the container platform, but then the container management and the build tools, they take over. They've been added in and they're taking responsibility for building the containers. Now, note something. The gray area that we have on the left is gone. So if we look at areas of ownership where each of these two groups might claim their stakes, there isn't any significant overlap in comparison. So advances in software, containerization, that has come along, actually has created a clearer border between the app logic and the system logic. And so advances in software, how will that affect the potential change within people? Well, our devs and our ops, it may be that they're given mutually exclusive areas of ownership. So I wonder if the gray area that we've defined is gone, that kind of brought people together, is the imperative for dev and ops to work closely together also gone? Thanks.